Well, we kind of ran out of time the other day after we got done with examples 1 and 2. And so we'll do 3 and 4 today and then finish up the worksheet. Here it says determine any relative extrema, again, any relative extreme values of that function on just an interval this time. And perhaps in just a little while you will understand why I have narrowed it down to an interval. Okay. And so if we're looking for extrema, what we're really looking for is where does it has to kind of change direction if it's going to create an extrema that's relative. Okay. So 1/2 x minus sine of x is actually continuous. There's no x value I'm not allowed to substitute in. And so from the interval 0 to 2 pi, we're probably fine. So we have to find places where it could potentially change direction. And how do you find those places? The derivative helps you. It's where the derivative is either 0 or undefined. Those are the critical numbers where it can change direction. Doesn't have to, but it can. So let's go ahead and find that derivative then. So 1/2 x, if you really felt like it, you could do product rule. It's a waste of your time, but you could. Okay. And so what is the derivative of 1/2 x? 1/2, that's pretty easy. And then minus whatever the derivative of sine is. And the derivative of sine is cosine of x. And then you have to take the derivative of the angle, but the derivative of this angle is just 1, right? So we don't have to worry about that so much. And so how about that? When will that be undefined? In other words, are there x values I'm not allowed to put in? Again, from 0 to 2 pi is really what we're concerned about. Or can I put in all the values from 0 to 2 pi and get a result? I'm never going to divide by 0. I'm never going to do anything weird. So yeah, I can, because cosine is continuous, and so we're good. But we do have to find out then where it equals 0. And so what's probably my best move here will be the next best suggestion on trying to solve this. Well, you could minus the half. I'd probably just add the cosine over to the other side because then it's all positive. So if you add the cosine over here, now this might be taking you back a ways. You got to get cosine off the angle because x has to get out of there somehow, so cosine's got to go. Can you just divide by cosine? Not really. You have to make it, I have to do its opposite, or its inverse. And the inverse of cosine is known as arc cosine, or a lot of times if you look on your calculator, it's just written as cosine to the -1, right? And if I do that on this side, though, I have to do it to that side. So really what we're doing is cosine to the -1 of cosine of x equals cosine to the -1 of 1/2. And of course, you could go and use your calculator. The problem with that is it's probably going to give you some weird decimals and things like that. And we like exact answers around here. And so these two cancel, leaving me with x. So it's x equals the arc cosine of 1/2. So in other words, where is cosine 1/2? And I'm only concerned about 0 to 2 pi. That one's pretty good. All right. So from 0 to 2 pi means go around the circle once, right? So cosine is the x value, right, on here? So that's positive. So there's only 2 quadrants that this can even be in anyways, right? And which 2 quadrants are those? 1 and 4. Very good. So I'm really not too concerned about anything over here, right? Because I need it to be positive half. Okay? And so cosine's the x value. And so we know half, well, let's face it, it is one of the major divisions, right? And let's just have a little review here. What is the ordered pair here? 1/3 is nowhere on any of these, but that's all right. Yep, square root of 2 over 2, square root of 2 over 2. Yep, 1/2. Wow, I don't even know what that was. I'm not even sure why I put that there. Anyways, 1/2 and square root of 3 over 2. Oh.
Okay, that was pretty good.
All right. So now, have we seen a half in there a couple times? We have, but now we got to figure out which one makes cosine a half. Cosine is which one again? It's the first one, right? It goes alphabetical. And so cosine happens being 1/2 there. And so, because our cosine means where does this happen, is really what it's asking. 60 degrees, but it gave it to me in radians, my interval, so we should probably do it in because it was 0 to 2 pi. So this is what? Pi over 6, pi over 3. Right? Remember, if you get stuck, 1 pi over 6, 2 pi over 6, you could do it that way. And so pi over 3. Is that it? Or does it happen again? Happens again. Of these three, if it's going to be symmetric, it probably happens at this one, correct? And that is, the ordered pair there is 1/2 and then negative square root of 3 over 2, right? And now we have to figure out what in the world that is down there, though. And there's lots of ways you could go about that. But remember, this one down here is 3 pi over 2, right? And if I make it over 6, do you agree that's, what, 9 pi over 6? So 10 pi over 6 is the next one, or 5 pi over 3, right? Everybody with me on that? How you can find that without pulling out your unit circle and having to do that all again. Okay? Does it happen anywhere else? If I just go 0 to 2 pi. So now do you see why I've narrowed it from 0 to 2 pi? Because if I just open it up to everything, do you agree that these would just keep happening? I would just keep going around that circle. I'd keep hitting the same ones. Ever and ever and ever and ever. And so we narrowed it down so that when we go and find our intervals, because now what we're going to do is we're going to try and find, well, where is this thing increasing? Where is it decreasing? And we have said that these are the only two places that this graph, between 0 and 2 pi, those are the only two places it can change direction. Okay, so what we're going to do is we're actually going to start at 0. How come I'm not starting at negative infinity? Yeah, the interval just says 0 to 2 pi, right? I know this one's continuous everywhere, and I could do that, but we're starting at 0, right? And then we're going to go, well, which one happens first? Well, which one happened first as we were going around the unit circle? Pi over 3 did, right? And then pi over 3 to close 5 pi over 3. Got to get to that one, right? And then we'll go from 5 pi over 3 all the way to 2 pi. And again, notice I am doing parentheses because I don't want to actually try those actual values. I want to try something in between there, right? And so what we're looking for is what's happening on those intervals. It has to be either increasing the whole time or decreasing the whole time. And I'm really kind of looking at my derivative, what happens to it, correct? So I really want to know what happens here, right? Lots of ways you can go about this. So let's pick something between 0 and pi over 3. Yeah, I mean, we've got a couple options over there that we already written down, haven't we? I mean, we wrote down pi over 4 over there. We wrote down pi over 6 over there. Doesn't matter. You can choose either one of those or any of the other ones in between, right? So which one do you want to choose? Probably one that pi over 4. We got it written over there, right? So let's find out what's happening at pi over 4. That's a pretty good pi, too. Because we know that from 0 to pi over 3, this graph has to do the same thing, either increase or decrease the whole time. And so what we're going to do then is we're going to put pi over 4 basically in here. And do you agree that basically cosine at pi over 4 is square root of 2 over 2? Right? For your knowledge, square root of 2 over 2 is about 0.707. So I'm going to do 1/2 minus 0.707. So it will be negative, right? So that's a negative. So let's choose something from, there's some very easy choices between, yeah, why not pi, right? That's a great choice, right? We're sitting over here at pi. Why would you choose that as such a good choice? Why would I say that? Is it? Negative 1 comma 0, right? Okay. So let's substitute in pi. So we're not going to substitute pi over 4 in this time. We'll just substitute in pi. So it's 1/2 minus a negative 1. Everybody good on that one? That this cosine of pi is negative 1 down here, right? So it's 1/2 minus a negative, so it's really plus, so it ends up being positive. And we chose what, pi? And it ends up being positive. But what if I chose something different in between there? Should I still get positive? Yeah, I should get the same. It shouldn't matter. I could have chose some just weird one, like right there. And it should still end up positive. It shouldn't matter. Okay? And now we need to choose something between 5 pi over 3. What is it? Okay, so in other words, he wants to try this one. Okay? And that one there is, right? And so we're going to try 11 pi over 6. Cosine at 11 pi over 6 is square root of 3 over 2, which is about 0.866 in decimal form. And so it's 1/2 minus that. So negative. So what did we say this is? Is this increasing or decreasing? Decreasing. And again, remember, if you're having somebody correct this on the AP, do they know what this means? Yeah, they know exactly what this means, but they actually want you to go back in there and say that this entire interval will be decreasing because the slope's always negative. And they're going to say that this one is always increasing, and then this one is always decreasing. Right? And so now we have to figure out what in the world that means. And it means basically if I was looking at the graph from 0 to pi over 3, it is decreasing the whole time. At pi over 3, it's saying, do I want to change direction or not? Does it change direction? It does because it becomes increasing, right? So at pi over 3, we have a relative, if it's going down then up, I have a relative min at x equals pi over 3, right? And then it knows that on this entire interval, it's increasing, right? Just like this one here. It's increasing, and then at 5 pi over 3, it has a choice. Maybe it's going to change direction, maybe it doesn't, and it does because it goes to decreasing. And so then we know we have a relative max at x equaling 5 pi over 3. Now, is this asking you about absolute max, absolute min? No. It's just asking about relative extrema here. And there are your answers. If you needed to, you could easily go and get the y values. If you need the y values, should you substitute those x values into the derivative? Because if you put them in the derivative, I can tell you what you're going to get. You're going to get 0, because that's how you solved for them in the first place. But if you put them back into the original, it will give you that value. And at that point, I would almost say just leave it as 1/2 minus cosine of pi over 3. You know, because that's going to be probably a better answer. Or go with radicals and stuff like that. I wouldn't go decimals at that point. I would keep it exact. Okay. So any questions on how we dealt with the trig? I mean, I had the graph there. I was going to graph before, but you all have the graphic. Most of you have the graphing calculators now, or could get one quick and do that. So I'm not too worried about that at the moment. Unless you want, because that's one way that we can kind of convince ourselves. We're visual people for the most part. But it works. You can trust me. No questions? All right. Now what? All right then. This has a vertical asymptote. Awesome. But it doesn't have a slant or a horizontal, right? Because the top's more than one bigger, right? Yeah, all right. I'm not sure that makes it better. All right, so now what? Relative extrema. So what do we got to do first? We don't have to find the asymptote. Not really. Find the derivative. Why are we finding the derivative? Because we want increasing and decreasing, right? And that's what tells us that. So to find this derivative, though, probably quotient rule, unless you want to move up the x squared and make it something else. It's up to you. Ooh. Or I could make you really mad.
No, you could make 1 over x squared plus 1 over x squared.
You can rewrite this one because it's a monomial on the bottom. Would you like to do that, or would you like to just review some quotient rule? Review quotient? Okay. For those of you that are wondering what I'm saying, seeing this as a monomial, you could rewrite this as, basically x squared plus 1 over x squared and take the derivative of that. It's the same thing. You see that? Because it's a monomial on the bottom. Because you just divide them both by x squared. But that's way quicker. But let's just do quotient just to review it. So how does quotient begin?
VU.
What does that mean, VU? I don't know what that means. Oh, bottom. There you go. Take the bottom, derivative of the top, which is what, 4x to the third minus. Now, does this have to be done this way? Yeah, it's subtraction, right? So you have to do it in this order. It's not like product rule where you can just do pretty much whatever you want. I don't know what that was going to be. I think it was going to be a 4 for some reason. I'm not really sure why. So it's x to the 4th plus 1. That's top. And then derivative of the bottom. Not all over 2a. No, it's all over. Yeah, the bottom squared. Any questions how I got to where we are at this point? No? Okay. So now, what do we got here? This term is 4x to the 5th. Be careful here. Minus. I'm just going to do it this way so that you make sure we don't make any mistakes. Minus, because I have to subtract all of that. So what do we got? 2x to the 5th plus 2x if I write it this way, right? All over x to the 4th. So it's really 4x to the 5th minus 2x to the 5th, which is 2x to the 5th, and then minus 2x all over x to the 4th. Yeah, we can take an x out. We can even take the 2 out if you want. It all depends on how much you want to simplify things. It's completely up to you. Let's go ahead and take a 2x out. And then we got what, x to the 4th minus 1 all over x to the 4th. I chose to do it this way to see what exactly it is that you want to cancel. That's why I chose to be a little devious on how I wrote this, and that's a really bad 4. Does this x to the 4th in the denominator cancel with the x to the 4th in the numerator? No. Can the x that's sitting outside cancel with this x right here, cancel with one of them here? Yeah, so in other words, the cleanest version that we can come up with, and realize you don't always have to get the cleanest version if you know that's really not what's being asked of you, and it's not. I'm asking for extrema here. So I could have used this version right here of the derivative if I felt like it. All right, but we're just going to clean it up a little bit. If we do, what do we got? A 2 x to the 4th minus 1, right, over x to the 3rd, right? That's our clean version of our derivative. That's a really bad x. So now we have to be a little bit careful. We have to find places where it could change direction, possibly, or change increasing to decreasing is maybe how I should say this. So what we're going to do is we're going to set it equal to 0. And the very first move we're going to do is multiply the x to the 3rd up, right? You multiply this up to here and it's gone. Okay. So in other words, I'm setting 2 times x to the 4th minus 1 equal to 0. And so now here's where people get a little bit confused. If you follow the factor version of this, you have to set 2 equal to 0 and find out what you get, right? Which is nothing. Doesn't make any sense. Or you can just divide both sides by 2, right? But now I have to set x to the 4th minus 1 equal to 0. Now you could do difference of 2 squares here and factor it. But again, when there's no linear term or extra terms, just move the constant over. And in this case, I have to take the 4th root. Very good. X is equal to positive or negative 1. So those are places it could potentially change direction or change from increasing to decreasing. But those are not the only ones. We have to find where it's undefined. X equals 0, I'm not allowed to substitute in, correct? Okay. So now here's where you got to use a little bit of thought. Ooh, that's a good one. So x equals 0. Do you agree that it is a problem in the derivative? Is that same thing a problem in the original? It is. So more than likely, that's not going to be a spike. It's going to be an asymptote of some kind. But at asymptotes, can you change from increasing to decreasing? You can. Okay. And so we still have to take those into consideration, but don't write it down as a relative max or min because the point's not there. All right. It's not a spike like those other ones. Okay. All right. Everybody good so far? Now what? So we know x equals 0. Do you agree x equals 0 is the only problem in the original? Right? So let's go ahead and set up our intervals. What should be my first? We're going left to right. Very good. Negative infinity, negative 1. Negative 1 to 0. 0 to 1. 1 to infinity. So you're starting to see how all this interval stuff, all this domain stuff, all of this is starting to come together a little bit because it's important information. All the asymptotes and all of that stuff. And so now what we need to do is we need to pick some value in each of these intervals to find out what that interval is doing. Again, make sure you don't miss any of the critical values because that can cause some real problems when you make your intervals. All right. And so negative infinity to negative 1. What do you want to try? Where are we going to substitute it in? Oh, it's right here. All right. Negative 10. All right. I've brought somebody over to my side. Good. Whoops. Why did I erase the x to the 3rd? Don't really know. Okay. So negative 10. If I put negative 10 in here, I'm in the derivative here. I know those that are listening in the recording probably can't tell that. But we're going to substitute negative 10 into those two places. And negative 10 to the 4th is going to end up positive, and pretty big positive, right? Minus 1, so that's really not going to do much, right? Still positive. Times 2 is positive, yeah. So it's positive over, and if I put negative in the bottom, negative to the 3rd is negative. So the overall result of putting negative 10 in gives me a negative. Okay. Now, do you have to do this little step here where I kind of write the top and bottom? Not really, but I think it helps me because sometimes I get distracted, you know, and then I forget what I was doing. And so then at least I have that there that helps me out. Unfortunately, this is not as easy to choose a value. Negative half, how about that? Or negative third, we really want to do a third? That's what my student said. Let's do a negative half. So we're going to put a negative half again into those two locations. Negative half when squared, though, becomes positive, but it's a fourth, right? So a fourth minus 1 is negative, times the is negative on top, right? And the bottom is still, do you agree if I put a negative in, I'm going to get a negative in the bottom? If I put a positive in the bottom, I'm going to get a positive, right? So this overall is positive, meaning it's increasing. And let's try a half, seeing we just kind of did the math for a half, right? So a half to the fourth is definitely positive, but it's only a quarter, or actually it's not even a quarter, it's 1/16, so sorry about that. It doesn't change this answer over here, though. 1/16 minus 1 is negative, right? Over, but the bottom becomes positive. So overall, it's negative. Just imagine if somebody walked in right now. You're like, what's going on? All right. You really want to do 3? Are you that? 3. The person that wants to do 3. Okay, so you put 3 in the numerator. And the top becomes, well, 3 to the 4th is pretty big, right? Minus 1 is still positive, times 2 is still positive. And the bottom is still positive, so end result positive, correct? So again, make sure you go in here and say this one's decreasing the whole time, this one's increasing, decreasing, and increasing. Okay, so now we have to kind of figure out what in the world that means. So what that means is on this entire interval, this graph is in some way, shape, or form decreasing, correct? Does it exactly look just like that graph I just made? Probably not, right? But it's decreasing the whole time. Does it change direction at -1? Does it change from increasing to decreasing? Yes, it does. It becomes increasing. I got to watch that change direction thing. Does it change increasing to decreasing? It does. So that means there is a relative min at x equaling -1. All right, so here it is increasing on this interval, and then at 0, maybe it changes from increasing to decreasing. Does it do that? Yes, it does. But it's an asymptote. Don't write it down as a relative max. The point's not there. All right? But this one here, decreasing at 1, maybe it's going to change to increasing, and it does. So we have yet a relative min at +1. I really want to force home, does everybody have that written down? I'm sorry. They're both relative mins. And in fact, they're absolutes. But basically, and maybe I'll just give you a sketch of the graph instead of getting really, really accurate. But anyways, basically it's kind of going like this and gone. And then like this and gone. Okay. So does everything meet from, if that's what the graph looks like, it says from -infinity to -1, it's supposed to be decreasing. Is it? Yeah, and from -1 to 0, is it increasing? Yes. From 0 to there, is it decreasing? Yes. And then increasing. Yeah, so it follows the rules, but do you see how 0, comma, whatever is not there? Because I'm not allowed to put 0 in the original. It's an asymptote. Okay. So do you see how you have to watch out with, is it a spike or is it an asymptote? Okay, you have to be very careful. And that's why we've worked so hard on domain. Is it in there or not? And 0 is not in this case. Okay. Questions?